Got the psychrometric chart here. Here's some outside temperatures today. 79, 99% RH at 5:30 in the morning. 7 o'clock was 82.90. 8:45 a.m. 85.82. Inside with a small air conditioner on. It actually was warmer inside. Humidity's about the same. So basically this has dropped the humidity radically. The temperature, very little. Okay, over here on the psychrometric chart, this is the outside condition. 5:30, 7, 8:45. So what's happened, the amount of moisture in the air is constant, but as it's heated up, actually the humidity has dropped. So it's just about saturated at 5:30 in the morning. Outside, the eavesdrops are dripping. Psychrometric chart. This is the dry bulb temperature here along the horizontal axis. That line there, the solid line here, is 80. It's 82. That's 85. These green lines are the humidity lines. It's 90% humidity, 80%, and 70. And since my gizmo over here is measuring outside temperature of on a it's 85 there, 81, wind speed of 2. It's on an Accurite weather center. Looks like this. Inside here is 80.49. What'll happen on this, when it gets up to about saturated, it'll lag a little bit because it takes a little bit while to dry out inside the unit, but it was saturated early in the morning. Got up, the eave troughs are dripping, and everything is just wet as can be outside. There's the wet bulb temperature, 80. So at 100% humidity is this line here. You have the wet bulb and the dry bulb the same. So if I take an 80 degree here, follow it up, and hits 80% wet and dry bulb, that's 100% humidity. So over here, if you go through and take the air mixture outside and it's just heats up, what happens is you got the temperatures going up and the humidity drops. You got the same number of grains of moisture per pound of dry air. Here it's about 150 in English units. But as you heat up, the humidity goes down because the air could actually hold more. If you took this air right here in the condition here, 845, and you added more moisture to 100%, you'd be back up to here. So you could add from right now at 150 pounds or grains, you could go up to 185 grains, 7,000 grains per pound. So this is kind of a weird chart, the psychrometric chart. And this Trane one is in English units. I think there's some on eBay that are in metric units. And it's kind of a funky chart that's a little bit of intimidating when you first use it. Got dry bulb here, wet bulb going horizontally in green. You got dew point temperatures here. And the dew point is different than the wet bulb temperature. When I first got into this years ago, I used to think it was the same. It is the same when you get up here at, I believe, at 100% humidity, but it's not over here. So if you took the air right here, this condition here, the dew point temperature is about 79. So if I took the air outside and just cool it down 6 degrees, you're going to have dew formed. And here it is. The wet bulb is 80, dew point is 79. The back of the chart here has an explanation on it. Air conditioning process, this horizontal line C sensible heating only. So the line that we're looking at is going horizontal to the left, and that's called sensible heating only. So outside it's heating up, and the dots are going to the left. Right now it is at, it says 85, 82, it's 85, 81. Now the air is flowing at 3 miles an hour across the bay here, so that adds some more uncertainty. And then this is kind of a hokey deal here that the weather center, take it with a grain of salt. It seems okay in an area that's closer to another air conditioner. It's 75 indoors and 58. This indoor temperature is actually inside the freezer, which is kind of strange with the remote unit. So this is closer to the another air conditioning duct here, so I've got a little bit more comfortable space here.